Machine Learning Roadmap. This is a step-by-step guide to becoming a machine learning engineer in 2026. In this roadmap, we will be discussing all of the stuff you will need to become a machine learning engineer. So, we will be talking about what are the prerequisites, what are the things you require to complete a machine learning course. So, while focusing on the practical implementation of machine learning, this roadmap is created. So, you can follow this roadmap and check out every stuff, and after that you will become a machine learning engineer in 3 to 6 months. So without further delay, let's dive into it. So here is the prerequisite for machine learning. You should know how Python works, and you can write code in Python. So you can create programs to do anything. So you have to have the hands-on practice on Python, so you can click on this and go for its roadmap. However, if you already know that, then you can move forward towards learning other stuff like machine learning introduction. So basically everything is here. You can click on each of the stuff and you will get every stuff, but we are giving our overview so you can understand it betterly. Then if you get more interested about it, you can follow this website to learn in depth about machine learning, and you can follow this roadmap to complete your whole course, and you will become an machine learning engineer within 3 to 6 months. So what is ML engineer? An ML engineer is a person who create and deploy machine learning models. And what are the difference between machine learning engineer and a engineer? ML engineer focuses on creating and deploying ML models, while AI engineer create the whole AI systems. So there is a big difference between them. AI engineer also do ML works, but ML engineer rarely do the AI work. So skill and responsibilities you have to know about ML engineers are ML engineers require a blend of technical expertise and practical abilities. These roles involve designing, deploying, and machine learning models to solve real world problems. However, if the stuff is mentioned here, you can follow them and learn the stuff by yourself. In the machine learning section course, we also required to learn the mathematical foundations. So here is the two stuff, calculus and linear algebra. So in calculus, you have to know what are the derivatives, partial derivatives, chain roots of derivations, and gradient, Jacobian, and Hessian. These are the concepts you have to know to complete your calculus section, and after that you can move on towards the linear algebra section, which are the mathematical foundations. So in linear algebra, you have to know what are the matrix and matrix operations, scalar, vector, and tensors, a singular value decomposition, determinants, inverse of matrix, and eigenvalues and diagonalization. These are the core concepts you have to know in linear algebra. Then you can complete your linear algebra section. Then you can move on towards the next section, which are the discrete mathematics. In discrete mathematics, you have to know what are the basics of a probability, bias theorem, random variance, PDFs, and types of distribution. These are the stuff you have to know in discrete mathematics. However, in discrete mathematics, we have few things like statistics also in this section, and probability also in this section, which topics we already have covered. So in statistics, we have something like basic concept, disruptive statistic, and graph and charts. Inferential statistics, you also have to know about it to complete your statistics section for basic mathematics foundation, which needs to be completed in ML engineering roadmap, so you can move forward. Then if you have covered the stuff, you can move forward towards programming fundamentals. First of all, you have to learn the basics, syntax, how we can write the programmings like variable and data types, data structures, loops, condition, exception, functions, built-in functions. These are the stuff which are the basic syntax you have to learn. After that, you can go towards the OOP. object-oriented programming, and in that section you have to learn some essential libraries, which are the NumPy, Pandas, Matplotlib, and Seaborn. These are the core libraries which you are going to use as an ML engineer, so you have to master this stuff. You can go for YouTube, voiceover, anywhere on Google, then search for this stuff and learn the stuff in a better way and master it, and then you can move forward towards the data collection section. So in the data collection section, we have data sources. The data sources are internet, APIs, mobile apps, IoTs, databases, SQL, NoSQL stuff. These are our data collection data sources. After that, you have to learn data formats. In ML, we have CSV, Excel, JSON, Prakriti, and other data formats in ML. And after that, you have to learn data cleaning. For data cleaning, you have to learn pre-processing technique, data cleaning, feature engineer, feature scaling and normalization, dimensionality reduction, and feature selection. Then we can move towards the actual machine learning concept. The stuff we have discussed are the prerequisite, as you have to start your machine learning actual stuff. So if you already know the whole other stuff which we have discussed, you can directly move on towards this section, which is dedicated to only for machine learning. So you have to learn what is machine learning. So machine learning is a concept by which you can teach or train a system to do the stuff which you really want. So actually you are teaching how to do stuff to the machine. So there are types of machine learning: supervised machine learning, unsupervised learning, semi-supervised learning, self-supervised learning, and reinforcement learning. These are the types of machine learning you have to learn. You just click on them and you will get all the resources you want. After that, here is a very big important stuff, which is Scikit-learn. It's used for data loading, training, test data, data preparation, model selection, tuning, and prediction. These are all the stuff you required to learn Scikit-learn, and after that you can master machine learning. Then we have to move forward towards supervised learning. What is supervised learning? You have to know, click on this and you can get the whole definition. Supervised learning is a type of machine learning where an algorithm learns from labeled datasets. So labeling also is another concept. You can search for it and understand it. I'm just giving overview. You have to search for each stuff or click on each stuff to get better understanding of how machine learning works. So after that, in supervised learning, we have classification, regression. These are the core concepts you have to learn. In classification, we have k nearest neighbors, KNN, logistic regression, support vector machine, decision trees, random forest, and gradient boosting machine. In regression, we have linear regression, polynomial regression, and lasso, right, and elastinet regularization. That's the stuff you have to learn. So in unsupervised learning, we have what is unsupervised learning. So let's click on that and learn it. Unsupervised learning is a type of machine learning where the algorithm learns pattern from unlabeled data. So it's just about unlabeled data. In unsupervised learning, we have clustering, dimensionality reduction. These are the two things we have in unsupervised learning. So in clustering, we have exclusive, overlapping, hierarchical, and probabilistic. These are the things you have to cover in clustering. After that, in dimensionality reduction, we have principal component analysis, auto encoders. These are the two things you have to learn to learn dimensionality reduction. Let's move on towards reinforcement learning. In reinforcement learning, we have uh, basically you have to learn what is reinforcement learning. So reinforcement learning is a type of machine learning where an agent learns to make decisions in an environment to maximize a reward. So that's the stuff you can learn it in depth to understand it better. So in this reinforcement learning, we have deep Q networks, policy gradient, actor critics method, and Q learning. These are the things you have to learn reinforcement learning. Then we move forward towards model evaluation. What is model evaluation? You have to learn. So model evaluation is the process of assessing how well machine learning models perform on a driven data set. Then you have to move why it is important, and then you have to learn metrics to evaluate. We have accuracy, precision, F1 score, recall, log, AUC, log, loss, confusion metrics. These are the things by which you can evaluate the metrics. So after that we have validation techniques, in which we have k-fold cross validation and LOOCV validation. Then we move forward towards the deep learning. So in deep learning you have to learn the basics of NNN neural networks, which includes precision, multi-layer perceptrons, and forward propagation, back propagation, active function, loss function. After that, deep learning libraries you have to learn TensorFlow, Keras, Scikit-learn, and PyTorch. Scikit-learn already we have learned, so we can move forward. In deep learning architecture, you have to learn conventional neural networks, which contain convolution, pooling, padding, and stripes. After that, you have to learn application of CNN, which includes image and video recognition, image classification, image segmentation, recommendation systems. Then you have to move forward towards re recurrent neural networks, which includes RNN, NGRU, LSMAT. While clicking on these stuff, you will understand what these things are denoted for, and you can learn them in better way. We are just seeing what are the things are included in the main topic, so you can understand and you can move forward, and while getting some pretty much idea about machine learning. So then we have to move forward towards attention mechanism, which includes self attention, transformers, multi-head attention. Then we have to move forward towards autoencoders, generating adversarial networks, and now it's time to move forward towards advanced concept in ML, which contain natural language processing, which includes tokenization, lemmatization, embedding attention models, stemming, and then you can go further for explainable AI, and this includes AI and data scientists, MLOps, AI engineering, AI agents. Visit the following related roadmaps so you can move forward while learning machine learning. However, you have completed machine learning roadmap and you can now become a machine learning engineer while following this. But for more advanced and more becoming skillful, you have to follow other roadmaps so you can better understand how machine learning actually work in practical way. So hopefully this video puts some value in your mind, and hopefully you have learned something. So thank you for watching. If you have any query, you can ask me. See you in the next video. Thank you. Bye bye.